Hello dear students, today we are going to take up the topic chapter 1 periodic table, how to find period and group in the periodic table. So let us start the session. So you can see the modern periodic table on your screen. So this modern periodic table are having periods and groups. So I would like to ask one question from you before starting the session. So basis of modern periodic table. What is the basis of modern periodic table? What is the basis of modern periodic table? So you might be knowing the answer now. So the basis is atomic number. Modern periodic table basis is atomic number. Let us go with the next question. Horizontal rows are called as. What are horizontal rows? So your answer is right. That is periods. Horizontal rows are called periods. So next question to you is vertical columns. Vertical columns are called as. Vertical columns are called as groups. Okay, right answer. So now the next question to you is, in the periodic table which we have seen over here, how many periods, how many groups? So you may be knowing the right answer. So I am showing you on the screen. Period 7, group 18. Horizontal rows are called period. Vertical columns are called groups. Okay. Let us go with the next part. What is electron configuration? Electron configuration is arrangement of electrons in the shells. We know we are having shells K, L, M, N. So the electrons are distributed in these shells. This is known as electronic configuration. For example, if we take sodium, sodium is atomic number 11. So 2 in K, L shell 8, and then M shell 1. So this is known as electronic configuration. So now you can see, you can think how to write electronic configuration of these elements. So you can see hydrogen 1 is there. If you talk of helium, it is 2, lithium, it is 2, 1. Similarly, nitrogen 2, 5. Oxygen 2, 6, fluorine 2, 7. So when we know the atomic number, we can write the electron configuration of each element. So now you can just think of what would be the next element. Next element will be neon, and the next element sodium, and then next element magnesium. In this way, we should know all the electronic configuration we can write and practice. So your task is you should practice all the electronic configuration for more clarity. So now the next part is we come to know now how to write electron configuration. The next is period number. How to find period. Period number is equal to number of shells. Like for example, we are having potassium, that is atomic number 19. So we know that electronic distribution takes place 2, 8, 8, 1. Similarly, there are 4 shells, so it belongs to 4th period. It belongs to 4th period. Can you think of calcium? Can you think of calcium? Calcium also belongs to 4th period because electronic configuration is 2, 8, 8, 2. 4 shells are there, so 4th period. Right? Next is, so period number is equal to number of shells. Now, for any element, if you want to know about, like I say, boron. Boron is 5 atomic number, so 2, 3. So 2 shells, period number 2. Similarly, fluorine. Fluorine is having atomic number 9. 2, 7 is the electronic configuration. 2 shells are filled, so we can say that to second period it belongs to. Similarly, we can come to know now all the elements, like how to find the period. So if someone asks me, okay, please tell the period of chlorine, you will write the electronic configuration, which is 287. And once you have written that, you will count how many shells are there. 3 shells are there. So 3 shells means 3rd period it belongs. Okay. Similarly, now the next is valence electron. How to calculate valence electron? Valence electrons are the electrons present in the outermost shell. Outermost shell is also known as valence shells. Okay. So now next part is how to calculate the valence electron. You know how to write electron configuration, so we can calculate the valence electron. So hydrogen it is 1. Helium it is 2 valence electron, lithium 2, 1 is the valence electron, beryllium 2 valence electron, boron 3, carbon 4, nitrogen 5, oxygen 6, fluorine 7. This way we can find the valence electrons. Similarly, if you talk of argon, 8 valence electron, chlorine 7 valence electron, sulfur 6 valence electron, phosphorus 5, 4, 3. This way we can find all the valence electrons. Now how to find the group number? Group number, there are two formulas. Group number is equal to number of valence electron if valence electron is 1 or 2. If valence electron is 1 or 2, then group number is equal to valence electron. If more than 2 there, then group number 10 you have to add. 10 plus valence electron. For example, if 3 valence electrons are there, so 10 plus 3, 13. So if 6 valence electrons are there, 10 plus 6, 16. Okay. So let us practice few questions for that. You can see now we are having beryllium. Beryllium is having atomic number 4. If you write electron configuration, it will be 2, 2. So now group number is equal to number of valence electron if valence electron is 1 or 2. So here it is 2, so group number is 2. Similarly, if you take the atomic number as 6, so that is carbon. Electronic configuration 2, 4. Valence electron is 4, which is more than 2. So here we have to add 10. 10 plus 4, it gives 40. So this way we can solve the electron. If you feel, you can stop and just practice that. Okay. Now finding valency. How to find valency is equal to number of valence electron or 8 minus number of valence electron, whichever is less, that will be more common. So now if you want to find the valency of beryllium, beryllium is having atomic number 4. If you write electron configuration 2, 2, valence electron is 2. So therefore valency will be 2. So now if you talk of neon, 2, 8, because atomic number is 10. So 8 valence electron. So now 8 minus 8 will be equal to 0. So the valency for neon is 0, right? So this way we need to calculate the valencies. So now finding the group number, now we can find any of the element group number. For example, let us say boron. Boron is 2, 3. So valence electron is 3. So more than 2, it is 10 plus 3, 13th group it will be. Similarly, if you talk of nitrogen, 2, 5, valence electron is 5. So 10 plus 5, 15. But if you take lithium, 2, 1, 1 means valence electron is 1, so it will belong to group 1. So there is one exception. So exception is helium. These formulas will not be applicable to helium. Helium belongs to 18th group. So you have to keep in mind that. So now if you talk of neon, 2, 8, number of valence electron 8, 10 plus 8, 18. Similarly sodium, valence electron 1, so it would be group 1. Magnesium group 2, aluminium group 13, silicon group 14, phosphorus group 15, and sulfur group 16, chlorine group 17, argon group 18. So this way we can solve the group number. So now what we have understood in this video is period are horizontal rows which are 7, groups 18 vertical columns that are groups. Okay, and you have also understood how to write the electron configuration and how to find valence electron. If valence electron are 1 or 2, so then it will be group number. If it is more than 2, then 10 plus the valence electron is group number. Period number is equal to number of shells, and valency is equal to number of valence electron or 8 minus number of valence electron. Helium will not be, we cannot apply this formula in helium. So these are the small points we will discuss today. So thank you for watching this video. So please tell others also. If you like this video, just download this application. You will find tests for practice, and if you want to know about some courses, then also you can contact us on this email ID and the phone. Thank you.